Okay, so in this fifth question of the exam, it's another kinematics graph review question, and in this case we're looking at the velocity time curve and looking at the concept that the displacement of an object is equal to the area underneath a velocity time curve. So in this case I'll break this again. You could do this in a more complete solution where you're looking at exactly from t equals 0 to t equals 10, but I'll break it down just so we can see the individual numbers and how they may appear in the choices. So the key concept here is that the delta x, the change in position, not the actual position, but the change in position, is equal to the area under the v versus t curve. So I'll first look at how far the object travels from 0 to 4 seconds. So the delta x from 0 to 4 would be and again this is the area of a triangle, is half the base. The base is a 4-second base. What's important to remember here is that the velocity is negative. So during this first 4 seconds the object is traveling in the negative direction, whatever way that is defined. So if this is the x direction, it will be traveling to the left. So in this case 4 times 4 is 16, and half of 16, which would be negative 16, will be negative 8 meters. So it travels negative 8 meters from its initial position during the first 4 seconds. And then I'll consider what happens during the next from 4 to 10 seconds. Again, it's the area of another triangle, which in this case it will be moving positively. So if we actually notice, the area from 0 to 4 is equivalent to the area from 4 to 8. So the object will actually have 0 net displacement over that first 8 seconds. So the net displacement will really be the area of this last piece, which you could also do the question that way. But I'll just go ahead and calculate the area from 4 to 10. So again, I'm doing half the base, and this time the base is 4 to 10 seconds, so that's a 6-second base, times the perpendicular height of the triangle, which is from 0 to 6 meters per second. So in this particular case, I have half of 6 times 6 is 36, so this is 18 meters. So the delta x net would be negative 8 meters plus 18 meters, which is 10 meters. So that is choice C, but that is not the correct answer because the question is asking for the position of the object at t equals 10, not the change in position of the object. So to find the final position of the object, we must consider the initial position of the object. So x final is x initial plus delta x. So you have to take into account that initial x equals 5 meters at t equals 0. So 5 meters plus the 10 meter change gives us a position of 15 meters, which is choice D.